Around 299 million years ago, the supercontinent Pangaea began to take shape, bringing nearly all of Earth's land masses together into one colossal continent. This massive shift altered global climates and environments dramatically. The interior of Pangaea was a harsh desert, far from any ocean, while its coastal areas experienced seasonal monsoons. These extreme environments shaped the evolution of life, forcing species to adapt to new and challenging conditions. Plants and animals had to evolve strategies to survive the arid deserts and unpredictable climates. The formation of Pangaea wasn't just a geological event. It was a turning point in Earth's history that would set the stage for dramatic changes in life and environments. The Permian period was a time of incredible biodiversity, both in the oceans and on land. Dense forests of seed ferns, conifers, and ginkgo-like trees covered the landscape, while the seas teemed with brachiopods, ammonites, and the last of the trilobites. On land, early reptiles and synapsids roamed, adapting to the varied environments of Pangaea. This was also the era of giant insects, as high oxygen levels allowed creatures like dragonflies and scorpions to grow to impressive sizes. These diverse ecosystems thrived, despite the challenges posed by Pangaea's extreme climates. The Permian saw the rise of new predators and prey, complex food webs, and unique adaptations, making it a critical period in the evolution of life. During the Permian, synapsids emerged as the dominant land vertebrates. These creatures, sometimes called mammal-like reptiles, were the ancestors of mammals. Synapsids like Dimetrodon and Edaphosaurus were characterized by unique adaptations, such as specialized teeth and sail-like structures on their backs, which may have helped with temperature regulation. Dimetrodon, often mistaken for a dinosaur, was actually a top predator of its time, preying on other large animals. The evolution of synapsids during the Permian laid the groundwork for the future rise of mammals. These early pioneers developed features that would later become defining characteristics of mammals, such as differentiated teeth and more advanced jaw structures. The Permian wasn't just the age of synapsids. It was also a time when early reptiles began to diversify and evolve into a variety of forms. Reptiles like Captorhinus and Pariasaurus adapted to the diverse environments of Pangaea, from dry deserts to lush forests. These early reptiles would eventually give rise to the dinosaurs and other reptiles of the Mesozoic era. Their ability to lay hard-shelled eggs on land allowed them to thrive in a range of habitats, paving the way for their future success. These reptiles were the forerunners of some of the most iconic creatures in Earth's history, showcasing the adaptability and resilience of life during the Permian. The formation of Pangaea created some of the most extreme environments Earth has ever seen. The vast interior of the supercontinent was far from the ocean, resulting in dry, desert-like conditions. These deserts were harsh and inhospitable, with temperature swings from scorching hot days to freezing nights. At the same time, the polar regions experienced intense glaciations, with ice caps covering large areas. The size of Pangaea also disrupted ocean currents and weather patterns, creating unpredictable climates. These extreme environments placed immense pressure on life, leading to the evolution of species uniquely adapted to survive in these challenging conditions. The supercontinent effect didn't just create deserts, it also led to intense seasonal monsoons along Pangaea's coastal regions. These monsoons brought heavy rains and flooding, creating lush, fertile areas where plant life thrived. However, the contrast between the arid interiors and the wet coastal regions created stark environmental divides. Species had to specialize to survive in either extreme aridity or seasonal floods, leading to a wide variety of adaptations. These extreme conditions set the stage for both incredible diversity and intense competition. As life struggled to adapt to these changing environments, some species flourished while others faced extinction. The Permian period ended with the most catastrophic extinction event in Earth's history, known as the Great Dying. Around 252 million years ago, nearly 90% of marine species and 70% of terrestrial species were wiped out. Scientists believe that massive volcanic eruptions in the Siberian traps released enormous amounts of carbon dioxide and methane into the atmosphere, triggering rapid global warming. This led to a series of devastating environmental changes, including ocean acidification, widespread wildfires, and the collapse of ecosystems. The oceans became anoxic, meaning they lost almost all oxygen, suffocating marine life. The impact of the Great Dying wasn't just limited to the oceans. On land, ecosystems collapsed as plant and animal species faced rapidly changing climates and habitat loss. The extreme heat, combined with the destruction of plant life, led to barren landscapes and the extinction of many terrestrial species. The scale of this extinction event was unprecedented, reshaping the entire planet's biosphere. The Great Dying was a turning point in Earth's history, paving the way for the rise of new life forms in the Mesozoic era, including the first dinosaurs. The Permian mass extinction left Earth almost unrecognizable, but life slowly began to recover during the early Mesozoic era. The survivors of the Great Dying, including small reptiles and early ancestors of dinosaurs, started to repopulate the planet. The extinction event cleared the way for these new groups to evolve and diversify, leading to the rise of dinosaurs, mammals, and modern plants. The Permian's end marked a new beginning for life on Earth, setting the stage for the incredible diversity of the Mesozoic era. This period of recovery and renewal highlights the resilience of life, even in the face of the most extreme challenges. Don't forget to subscribe to see how life rebounded and transformed after the greatest extinction event in Earth's history.